Naming monatomic ions. Monatomic ions consist of one atom with either a positive or a negative charge. This comes from the atom taking in or losing at least one valence electron. Losing an electron gives the ion a positive charge, making it a cation, while gaining an electron gives it a negative charge, forming an anion. Elements that are metallic usually lose valence electrons, so they all carry positive charges. Ions from group 1a end up with a 1 plus charge. Ions from group 2a have a 2 plus charge, and so on. In group 3a, where ions have a 3 plus charge, aluminum is the only common metal. Cations are named by using the element name followed by the word ion or cation. For example, barium forms a cation either called a barium ion or a barium cation. Nonmetals usually gain electrons, so they make the negatively charged anions. To find the charge of any group A anion, subtract 8 from its group number. For example, chlorine is in group 7a. Its anion has a 1 minus charge, as 7 minus 8 equals negative 1. However, most of the elements from groups 4a and 8a don't make ions. Anions are named by adding the suffix IDE to the element's name, like chloride for the chlorine ion. But there are still transition metals. Many of these metals in groups 1b to 8b make more than one cation with different ionic charges. These charges have to be found for the number of electrons lost. For example, iron can make two common cations, Fe2+ and Fe3+. There are also some exceptions, like silver, that have only one ionic charge. Transition metal cations have been named two ways. The current naming convention is called the stock system, where a Roman numeral in parentheses is put after the element's name to show the value of the charge. The Fe2+ and Fe3+ cations are now called an iron 2 ion and an iron 3 ion. The older naming style used the root names of the elements. The suffix OUS was used to denote the cation with the lower of the two charges, while IC was used to show the higher of the charges. Fe2+ would now be called ferrous because it has a lower charge than Fe3+, ferric. This can be deceiving in two ways. First, the classic Latin names of some elements are used instead of the normal names. This can be solved by looking for the element symbol in the name, but in some cases like tin, the name stannous can be confusing. The system also doesn't show the value of the anion's charge, just which of them have the higher and the lower charges.